Hello, in this video we're going to take a look how to represent sum in sigma notation. First of all, we have to find general term for our sum. And to be able to find a general term, and we have to know what kind of series is this. And as you can see, this is arithmetic series because we have common difference between the terms 1/3. Because 2/3 minus 1/3 is 1/3. 1 minus 2/3 is 1/3. Now, remember the general term is a1 plus d times n minus 1. Okay, what is our first term? Our first term is 1/3, is right here, is a1, plus what is d? D is actually, remember the common difference, which is 1/3 and minus 1, and this is our general term. Now what we have to do, we just have to plug in sigma notation. Remember, our sigma notation in general looks like I starting point, okay, starting to the n, and ai. Okay, and what is our starting point? As we can see, a1, 1 2 3 4 5 6, this is our places, and sigma notation will be, we're starting at I equals 1, and we have totally 1 2 3 4 5 6 of them, and a, what is our ai, is just what we had before, 1/3 plus 1/3. Now instead of n we should use actually I minus 1. This is our sum in sigma notation without simplification. Now actually what we can do, we can simplify this. Simplify this expression by distributing 1/3, and we have 1/3 plus 1/3 n minus 1/3. As you can see, 1/3 minus 1/3 it just cancels, and we have actually our general term 1/3 n. Again, using this sigma notation, what we can do, we can express our, remember, starting point. Again, I is equals, we're starting at 1. How many terms we have totally? 6. And our general term is 1/3. Now instead of n, using I. And this is another representation. But these two ways, not the only way. Actually, you can come up with something else which will represent the same sigma notation, the same sum. Now if we start, let's take a look. If we want to start at, using sigma, at I equals 0, if I want to start like this, let's see like the, what's our actually terms are 0, 1, 2, this is third, this is fourth, and this is fifth term. Now if we're starting this way, our first term should be 1/3. It means we should find some general formula for the 1/3 for our series that will give us 1/3 when I equals 0. To be able to do this, we should have 1/3 plus 1/3, our common difference, times I. In this case, if we plug in 0 for our general term, and we have 1/3 plus 1/3 times 0, and as you can see, this one cancels, and we have just 1/3. What about our Next term is a1. a1 equals 1/3 plus 1/3 times 1. As you can see, 1/3 plus 1/3 will be just 2/3, which is true, like you can see here. Okay, let's find our last term, but in this case our last term is actually 5th. That's why we have to write our last term here is now already not 6, it's 5. And let's check if it will be 2. Let's a5 equals 1/3 plus 1/3 times 5, and what you can see, 1/3 times 5 is 5/3 plus 1/3. It will be just 6/3 or 2. And as you can see, it works, and it means we come up with another solution for our problem, and we have totally 3 of them, 1, 2, 3, which look different, but they're exactly the same.